Good day, everyone. Welcome to 24 Hours Have Passed, the evolution of the data platform. We're very happy you could join us today for Mark Broadbent's session, Schizophrenic High Availability with SQL and Windows 2016. This 24 Hours Have Passed event consists of 24 consecutive live webcasts delivered by expert speakers from the past community. This is the 22nd of those 24 sessions. The sessions will be recorded and posted online after the event. Just visit www.24hoursofpast.com for the session links. I'm Sharon Dooley. I'm going to be moderating the session. Many of you know me from my involvement with the past DBA virtual chapter. There's a slide up now that shows about technical assistance. If you have a problem, please type your inquiry into the questions pane on the right-hand side. You will see a Zoom button at the upper left-hand corner of your screen, and you will be able to maximize your screen or make it the size that works for you. There will be a short evaluation of the session. Your feedback is important, and so please take a moment to complete it. It will appear in your web browser. Thank you, Mark. We'd like to thank our presenting sponsors, Microsoft, Hortonworks, Amazon, and Redgate. They make it possible for us to do these 24 hours of pass. We also appreciate the support from Hewlett-Packard, SQL Sentry, and SanDisk. The staging of 24 hours of pass wouldn't be possible without this support, and they're the reason we're able to make this available to you free of charge. Next slide. If you're not already a member of PASS, you should be. It's free to join. It's a nonprofit international community of SQL Server users. We have year-round learning opportunities for SQL Server folks. There's online training. I mentioned the virtual chapter that I lead. There are dozens of them, and most of them have monthly or bi-monthly meetings. You can sign up for the mailing lists for those virtual chapters that you are interested in. We also have regional chapters, which have a physical presence and usually have monthly or quarterly meetings. That's a chance to meet people in your area, network. Usually you get food. It seems to always be pizza at our local user group. Maybe we'll have something different tonight. I'm speaking. I should have asked for something different. Next slide, please. Now, our speaker is Mark Broadbent. He describes himself as 30 billion times more intelligent than a live mattress. I'm not really sure what that means because my mattress doesn't seem to have a brain in its head. He's a Microsoft Certified Master and Certified Solutions Master. He's a Microsoft Data Platform MVP, and he's the principal at SQL Cloud. His email contacts are on the screen. He was the event lead to the United Kingdom's first ever SQL Saturday in Cambridge, and there's another one coming up in September. There's going to be pre-cons and a community day, and the URL for that is on the screen as well. And if you're not going to be in Cambridge, check out a SQL Saturday near you. They're all over the world. They're free and well worth attending. And now I'm going to turn the meeting over to Mark so that he can do his presentation.
Great. Well, thank you very much, Sharon. It's actually an honour for you to be moderating me. I know you do an awful lot for the community and don't get enough credit for doing it, so thank you very much for being here and supporting me. So today I've called this session Schizophrenic High Availability. Probably called it that because I probably expected nobody to turn up, so it'd be me talking to myself for an hour. But in reality, the SQL Server and Microsoft Data Platform has changed so much over the last, I don't know, 5 to 10 years that high availability solutions now have changed beyond recognition. You don't really know what they're giving you. Are they giving you HA? Are they giving you DR? Are they even giving you scale? Or perhaps they're giving you all three. So what I really hope to achieve today is to really discuss some of these areas of interest. I obviously won't be covering the entire Microsoft Data Platform stack. That's probably for somebody else, somebody more qualified than myself to do sometime. In fact, visit the PASS Summit and I'm sure you'll see most of these sessions. So that's what I'm hoping to achieve today. I've been told that my ugly mug is probably not suitable for the entire broadcast. It also will probably slow the broadcast down, so I will probably take my video off, so apologies if you find me incredibly handsome and want to watch me through the session. I'm very sure you don't. So let me just take myself off the screen now. Then I don't have to look at myself as well. So just to answer Sharon's question as well about me being that many times more intelligent than a live mattress, the whole point of the statement is that a mattress isn't intelligent, so I can be a billion times more intelligent and I'll still not be very intelligent. That's kind of how I feel about myself. So anyway, moving on. Today we're going to talk about, well, we're going to start off of how exactly did we get to schizophrenic HA and exactly what is schizophrenic HA. Then this topic I found a lot of DBAs are not really as interested in as they should be, but from a high availability perspective, I personally think DBAs really should be interested in cluster storage. And then we're going to move on and talk a little bit about virtualization. I know virtualization and SQL Server is a bit of a dirty word, but I believe times have changed now, so we really should be thinking about virtualization for our HA strategy of SQL Server. We'll then move on to some new and cool high availability features in SQL Server 2016. And finally, I always think that the best part of my presentation is when it's ended. So I'd normally offer the audience to join me for a gin down the local bar, but obviously we won't be able to do that this time. So I'll definitely be having a drink after my session, and I hope you can join me virtually. So in the beginning, SQL Server HA was fairly straightforward. If you wanted HA, there wasn't really many options. The only options you really had were replication, which seems to have been with the product forever, and SQL Server Failover Clustering. So my first introduction to failover clustering was with SQL 6.5 on Windows NT4, and I was kind of dropped into that environment. I was a manager at the time, and I owned that environment, and I didn't know anything at all about failover clustering. So because I didn't know anything about it, I was very fearful of change happening, and I banned anyone from touching it. And one day, somebody let a third party into the server room. They installed an application on one of the nodes, and the entire cluster died. And for the next 6 months, I struggled to try and get the thing running again. So ever since that day, I've always sworn that I don't ever want to be in that situation where I don't understand the technology that I'm managing. So this is really how I got into high availability and SQL Server, in fact. Now, in the beginning with the hardware, it was very, very simple from a clustering perspective because the hardware really determines the high availability. We would have our cluster nodes and local storage that was configured in a shared setup so that both nodes could have visibility to that cluster storage. So this is all local. We could only ever have a single SQL Server failover clustered instance. And the restrictions in NT4 as well is that you could only have 2 nodes. So for those of you wondering where the term active-passive came from, this was it, because if we could only have 1 SQL Server instance and there was 2 nodes, then there would always ever be a passive node. So hopefully that enlightens you a little bit on that scenario. But things were very straightforward. We knew exactly what we needed to get from a hardware perspective. It needed to pass the certain criteria that Microsoft had for clustering at the time, and things were fairly simple. Storage was local. There was no difficulties there. So really I just want to talk a little bit, for those of you that know clustering and availability groups, you can go and have a cigarette now. But I just wanted to touch on those 2 technologies a little bit for those people that don't really understand what clustering and availability groups are. I want to explain them to you. So what is clustering? Well, SQL Failover Clustering is essentially the ability to synchronize the running of a SQL Server instance across different nodes. And there's no real magic involved here. What really happens is we install SQL onto one node and then we join, so we do another installation on another node or many nodes and join that installation into our original installation of SQL. So the cluster is really synchronizing which of these SQL services are running at any one time. The cluster, though, needs to also know that each node is active and live and there at any one time as well, because it could be we have a scenario such as a split brain where we lose connectivity between the nodes. So the cluster needs to understand which node it has lost connectivity to and which node can be considered live. And it does this through a mechanism called quorum, which is really a voting mechanism. So this is another thing that the cluster provides. It provides quorum. This is probably one of the most important things a cluster provides. Now we can also cluster across into another subnet, so another site. And if we are doing that, though, we have to have some form of storage replication under the covers in order for that other node to have visibility to that storage. And then we have all the typical considerations such as IP addressing and name resolution and all these kind of things that as DBAs we've come to become familiar with. So availability groups was quite interesting when it first came out, and it was one of the first times I think that the Microsoft product teams have reused a technology from another product team in order to arrive at their solution. And what I'm really referring to here is the cluster side of things. So in order to provide a different style of HA, Microsoft wanted to be able to take a set of databases, very much like database mirroring, and replicate these databases to other nodes. They're called replicas. And we needed somehow there to have a mechanism of quorum. You'll remember that database mirroring used a witness server, a witness instance. And so the SQL Server product team thought, well, how can we do this? And also there's a few other HA components that needed to have HA, such as the availability group component itself and the listener as well, which is something that is a highly available network name which resolves to an IP address. So they looked at what was out there and thought, well, the ideal solution for this is a Windows cluster, and it really is in many ways. It provides somewhere for these high available components to be housed, and also it provides quorum. So almost a perfect fit. But the only problem with this is the fact that at the time, and certainly up to Windows 2012 R2, the fact that a Windows cluster is involved means that we have all the restrictions of a Windows cluster. There is a single domain requirement, and this really means that people that were using database mirroring, and they may not have a single domain, you can obviously mirror to different domains using certificates. This caused a bit of a problem because it meant that Microsoft could not remove database mirroring until they've solved these problems. So that's availability groups and clustering in a nutshell. What exactly do I mean by schizophrenic HADR then? So if you think about all the different platforms out there and all the possibilities, there are a significant amount of things that we can use in our HA solution. So let's think for a minute about storage. We've got now several options of storage. In fact, more options than are really listed on this slide. So we could use the traditional style of storage that we always did for our shared storage for our clusters, for instance, and that would be provisioned via fiber channel. So these are our SANs that are being provisioned to our nodes via HBA cards. Or we could use a deviation of that over Ethernet called iSCSI. But there was also an interesting development in SQL Server 2012, I believe, where we could also have now file shares. We could install SQL Server to file shares. We could create databases on file shares. So that was quite an interesting development. From a physical server perspective, well, we don't necessarily need to have physical servers. We could have virtual servers or virtual nodes in our solution. And talking about virtual nodes, that brings us on to Azure, the cloud. We can have VMs in the cloud itself, so you don't necessarily have to have an entirely physical deployment for your HA strategy. We could have something that's on-premise, something that's in the cloud. There are lots of other options in the cloud as well. We have different types of storage. We have blob store, and blob store comes in two forms. We can have page-style blobs or block-level blobs, and I encourage you to look up the difference between those two things. And there are obviously other products such as Azure SQL database as well, which we will be seeing that it's used in a particular style of hybrid deployment later on. So there's lots and lots of different options here, and they're all giving us lots of different things. Some of them are giving us a little bit of scale, some of them are giving us some DR style functionality, and some of them are giving us HA, which is primarily what I'm after. Right, so let's talk a little bit about cluster shared volumes, because I'm really a big fan. So cluster shared volume support first came in SQL Server 2014, and prior to that, I believe it was introduced in Windows 2012, but prior to that I've discussed all the ways that you'd really provision storage to a SQL Server cluster, but CSV's really changed the picture somewhat, because if you imagine the situation, our classic scenario in a cluster where, let's say we have 5 different SQL failover clustered instances installed into our Windows cluster, and each one we provision 5 different drives to each SQL instance. That's 25 potential drives. Now, we're going to run out of drive letters provisioning that many disks to our SQL instances. So what we would traditionally start to do is we'd use mount points, and so we'd have one cluster disk that would act as the root, and all our other disks would be mounted from directories off that disk. But that can become a little bit messy, and certainly for those people that don't really know clustering too well, those DBAs that aren't really that familiar with clustering, this just adds a little bit of extra complication to the picture. Now also there's another problem with traditional storage, because if you imagine that a cluster, a failover cluster instance can only run on any node at any one time. So we have this concept of ownership. So there's a bit of a problem, because in the traditional deployment of a SQL failover clustered instance and clustering in general, we could only ever have a disk presented to a failover clustered instance at any one time. And this again has certain implications. It has implications for failover times and other things as well. So in comes cluster shared volumes. Now it's not a different type of storage. What it really is a highly available clustered file system that's wrapped around our traditional storage. So all these disks that you have presented to your Windows cluster nodes, let's just assume they're not currently in use. All you would need to do in order to make them cluster shared volumes is right-click them in your available storage and say add to cluster shared volumes. Now this gives us some amazing benefits. What it does is it means that we can install all our failover clustered instances into the same CSV if we want. We can, and what that would mean as well is, from a storage perspective, you have to start thinking about your SAN layouts. Do you actually start provisioning lots of smaller drives as you did before for logs, backups, data, or do you start now thinking about having larger drives that are not dedicated to one SQL instance? So, and also a very interesting thing, when you first start using cluster share volumes, you'll be surprised to see that there are no drive letters at all. So what the Windows cluster actually does behind the scenes is it creates like I call it a pseudo mount point off the C drive, and so when you add a brand new volume into cluster shared volumes, you'll see a directory called something like cluster shared volume, and then under that the volume name. It's very important at that stage that you think about renaming the volume name if you actually want to have a name, because you cannot do it post installation. The cluster share volumes are visible across all the Windows nodes at any one time as well, which, as I say, means you can install multiple SQL instances into the same CSV. Now the reason that is possible is because there are no persistent reservations needed to be taken against the volumes, because we no longer need this one-to-one mapping between SQL Server and the volume. We don't need ownership as such, but there is still what's known as a coordinator node. But also, as I mentioned earlier, we have SMB3 file shares. This is arguably a lot easier to use than CSVs, because all it means you need to have is you need to have a file share available somewhere, and obviously your Windows cluster nodes have to have connectivity to that file share, and the right security rights for SQL Server service need to be present on the file share itself. So that's very, very easy to do. Not all functionality is supported. You can see, for instance, that file stream support is not there, but it's very easy to do. Now this really raises a question: which one do we go for? Do we go for CSVs or file shares? One thing I didn't say about CSVs is that because it's a highly available file system, a node could lose connectivity to the CSV storage, but as long as another node has visibility to that storage, then there'll be no failover. What it will do is it will reroute traffic via another node that does have visibility. So that has network implications. Now file shares present a similar kind of HA picture as long as you're using a technology behind the scenes called scale out file server, and this is really happens at the network stack. So I encourage you to go and, there's a very good white paper on scale out file server, and I encourage you to go and read that, that white paper. So I'm not really going to be forced here to give you my answer. What do we use? Do we use a file share for our SQL Server, or do we use CSV? At the moment, you could use both, but my feeling is that I will tend to CSVs until I know that there is going to be a very high-speed, highly resilient scale-out file server behind the scenes for our file shares. So that's really my take on things. Now, there was a time when we had to worry about whether we provided a witness disk or not to our cluster. So generally what would happen is if we had an even number of nodes, we would configure a witness, a disk witness or a file share witness to our cluster to make an odd number of nodes, and this witness was simply used as an arbitrational vote in the cases where the cluster needed to use that vote. Now in SQL Server 2012, sorry, Windows 2012 R2, we have what's known as dynamic quorum now. So the advice is that we always configure a witness onto our cluster. The cluster itself will determine whether that vote is needed to increase the vote maximum or not, and it will dynamically stop using that vote if the total number of votes changes. So if we have a cluster node failure, for instance, it will dynamically decrement that, it will dynamically stop using that witness if it needs to, all in the interest of high availability. So considering that we have to, or we should always create a witness now, where do we put it? Advice in the past has always been to put it on a third site, or another site at least. If you only have one site, then there's going to be problems there. So you don't have as much HA as you could have done. And this could be a bit of a waste, really, because it may be that if we're in the multi-site deployment scenario, it may be that we don't have a third site, we just have site 1 and site 2. So it could be that you would have to be forced to put your witness on whichever site you consider the most important. Now that's not really the greatest place for the witness, but in Windows 2016 we can actually now create what's known as a cloud witness, and it's incredibly easy to deploy. And all it is simply a blob store, and when we configure the cloud witness on our cluster, it simply creates a blob container, and then it will dynamically use this for arbitration when it needs to or not. So I'm hoping that my demo is not going to fail here, and let's see if I can succeed in showing you how to add a cloud witness. The first thing I am going to do then is that I'm going to go into my Azure account, and I'm going to find the blob that I've created for the witness. So TD witness, hopefully you can all see this. And all I'm doing here, so all I did is I just created a brand new storage account and created this blob. And the only reason I'm here is to actually grab what's known as a shared access key. So I'm going to copy this now, and then I'm going to go to my cluster here. I've got a 5-node cluster. I know the screen is a little small, but I'm hoping you can see this. And so normally when we want to change the quorum configuration, we right-click the cluster itself, More Actions, Configure Quorum Settings. So we'll get this nice wizard, and we can do this on the fly with no risk to downtime to our cluster. So select quorum witness. You'll see this nice option now, configure a cloud witness. So the storage account name, if I remember correctly, was TD witness. And this is where we put our SAS key in, so I just need to do a paste there. So hopefully if my default gateway is configured correctly for this machine, this is going to work. If it's not going to work, it will fail in 30 seconds. Right, so that's great. We can now see below, unfortunately I don't have Zoom on this machine, which is a pain. We can see below now, we can see our cloud witness has got this lovely cloud symbol. So that's fantastic. We've really easily utilized Azure for our HA strategy. Apologies if you can hear a lawnmower outside. I don't know who that is. It's probably my next door neighbour trying to annoy me. So we've utilised Azure, and in a way that's incredibly cheap, because we've no longer needed a third site to house our witness at all. And the cost of the blob for this witness is incredibly low, almost negligible. One thing which would probably be worth just showing you as well is that in our TD witness, sometimes when you're using blobs to do things, you always have to create a container. As I mentioned earlier, the cluster actually creates a container for you, and it creates this container here. And you can use the same blob for lots of different witnesses as well if you need to. So hands up, who's using virtualization for your SQL servers? I don't think there's many people that put their hands up. Well, I personally think things are changing. Obviously there's a lot of advice out there saying not to use virtualization for SQL servers because it's adding an extra layer of obfuscation, which is true, that's still the case. But let's just assume we can get over the obfuscation situation, and we can work more closely with our virtualization professionals. If we actually know what's configured and under the covers, and we have a say in it, then there is absolutely no reason these days to avoid virtualization, assuming of course the virtualization platform can scale for the guest to the level that you need it to scale to, and most of them can. And if you do utilize the virtualization platform, you get some fantastic benefits. Now I'm going to focus really on Hyper-V. The reason being is because I've really bought into the entire Microsoft data platform and stack. I think obviously there'll be VMware fans out there saying that VMware provides higher potential for the guests, higher capabilities, and that is definitely true. And there is also some compatibility for VMware virtual machines in Azure, but what I would argue is that if you stick to using Hyper-V, you are pretty much guaranteed the maximum amount of compatibility with your cloud solution. So that's why I'm really sticking to Hyper-V, but obviously VMware is a great product and an alternative. So Hyper-V provides lots of different HA style benefits and DR style benefits, one of which is replication. What that really is, it's a periodic copy of your VM which is shipped to another Hyper-V host somewhere else, and that really provides you a mechanism to very rapidly recover should you corrupt your original VM. So it could be that you're rolling out a patch, for instance, and it all goes horribly wrong, or you get a junior DBA to update SQL Server and kills it. So this really is a good way to kind of protect. It's one level of protection for that kind of scenario, and you can have replicas of replicas as well, which is pretty cool. Quite basic and a similar mechanism to replication. There's these things called exports. So you could kick off an export of a VM and just create a complete copy, end-to-end copy of your virtual machine. So you could do this for all your important SQL guests and just have these in standby just in case you do have corruption happening. When I say corruption, I'm talking about the OS corruption. We also have some fantastic HA capability in what's known as live migration and live storage migration. This is pretty much zero downtime failover to a completely different physical host. This is really, really cool when you see this happening. You'll probably lose about 1 ping. And quick migration is really the precursor to live migration. I've never really bothered timing how quick migration is compared to live migration. In fact, I would argue it's slower because it actually has to take the virtual machine offline before the failover. So I would avoid quick migration. Checkpoints are something you should probably think about doing before patching, and then obviously if a patch is successful you can delete the checkpoint. These are the same thing as VMware snapshots, and all these are doing is creating deltas of changes to the guest. And we also have with virtual machines Azure, very easy Azure portability, so we can using different Microsoft products can fail over into the cloud, fail the actual VM itself over into the cloud. So that's pretty cool. Now I've got a scenario that I've talked about in the past, and I actually quite like this configuration. If you didn't like running SQL Server on a virtual machine, then you'll hate this even more. So the scenario is this: we have a Hyper-V cluster. So the Hyper-V cluster is providing very fast failover for our VMs themselves to different physical hosts. But then on top of that we can create what's known as a guest cluster. Why on earth would we create a guest cluster in VMs? The reason being is because the Hyper-V cluster is providing HA for our virtual machines, but the SQL Server failover cluster is creating HA for our SQL Server instance. So let's imagine that one of our SQL cluster nodes, the VM itself, let's say the one on the left-hand side, gets corruption. No problem. Well, hopefully we'll have an automatic failover, but if not, we'll perform a manual failover of our SQL FCI to the other VM, and pretty much very, very, very low downtime. So I really love this kind of deployment. One thing to bear in mind though is depending on where all your fabric is located. If it's all located in the same cabinet, then you're pretty much wasting a lot of your time doing this. So you want to seriously consider where your infrastructure is deployed. I absolutely love SQLXI, and we're talking about SQL 2016 today, so I'm here lying to you about me talking about 2016, because here we have a capability that was available in SQL Server 2014. Now, what this is I think it's really cool. What we can do is we can have an on-premise SQL Server instance, or even a IaaS VM deployment of SQL Server in Azure, in the cloud, and we can actually create databases in Azure blobs, which I think is really, really cool. From an on-premise scenario, I do wonder whether there is much purpose of doing that, or creating a completely pure database in the cloud from on-premise, although I will be giving you potentially an idea of one way we can utilize this in cloud file groups. Another thing to mention really with the use of blobs for storing SQL Server databases is it provides portability. So let's imagine you've got a cloud IaaS deployment of SQL Server, and it's not using virtual disk, it's actually using blob, then you could very easily decommission that VM and have a new VM, which then repoint that to this blob storage very easily. So that's really a really portable way to move your databases to other machines. And one reason why I can justify slipping this technology into my slide deck is really because there's a technology called file snapshot backups in Azure, and the prerequisite for that is to actually have your data files in Azure too. I'm not going to talk about that anymore, but I strongly encourage you to go look up file snapshot backups and investigate that, because if you are using data files in Azure, you'll be amazed at how useful this is and how quick this technology is for doing very large backups, and how much it simplifies your life. Now, moving on from SQLXI and talking about cloud data still, we have this brand new functionality in SQL 2016 called Stretch Database. Very easy to set up. You can see you just have to run the spconfigure command to enable it for the instance, and then we configure a database to be enabled for Stretch, and the way that works is we just select whatever tables, assuming they pass validation, that we want to stretch. Behind the scenes there's a trickle thread, and this will periodically and continuously run in the background and trickle rows across into the cloud, and this actually trickles across into SQL Azure database. Now the use case for this really is for cold data, so archiving data for maybe audits that you don't really want in your tables anymore. But the beauty and the reason it's called Stretch is that you can, if you want, transparently query into the cloud. You won't even know you've done it, apart from if you look at the query plan, and that will show you that you've done a remote query into the cloud. There are, however, some restrictions with using this this technology. However, and I would also caveat things with saying it's version 1, so very early days with Stretch, but you can guarantee that this is going to be improved upon in future versions. So I'm going to try and do a demo now. If any demo is going to fail, it's probably going to be this one. So this morning I'm hoping I cleared everything down, so I won't bother running the teardown script. Maybe I'll make sure the credentials deleted though. So the first thing we need to do, we need a blob for SQLXI, as I explained, and so we create our blob in the cloud, and we need to have a credential. We also need to provide an access policy. So in order to do this easily, I use Azure Storage Explorer. So what I'm going to do, in fact, if I right-click here and click on Manage Access Policies, you can see I've defined a couple of policies there, and they have expiry dates. So I'm going to now get a shared access signature, select one of my policies, hopefully I'll select a good one, and click Create. So you see it here, we have the query string, so I'm going to copy, and then I'm going to add this as our credential for this particular blob, and this allows the instance to connect to the blob. The bit that I need to take off this string is that. Let's just create our credential now. Select from the credentials, it's there, good. You'll see this create database command. I'm specifying the blob and the container itself to store my data and log files. And hopefully this will work. So interestingly, for me at least, you see that your paths are not what you'd expect them to be anymore. So this is one way to give junior DBAs a real scare. So what we can do now is, just to prove to you this works, I'm going to create a table, insert loads of records into the table, and I'm going to show you the execution plan of doing so, because what I want to prove to you is this is entirely transparent to SQL Server. It just, as far as it's concerned, it's using just a piece of storage. It doesn't really care where that is. Now, I was talking about a potential use case for on-prem, off-prem, and the one I came up with is I wasn't sure whether you'd be able to have like a hybrid database, so you could have on-prem file group and have all your hot data, for instance, in this file group, but then we may want to be able to archive stuff into the cloud very easily. So this is very much like Stretch database, but more manual. So I tried this out, created a secondary file group in the cloud. Hopefully those files don't currently exist, and I was very pleased to find that that works. So from an archiving perspective, if you don't think Stretch is quite there or ready for you with version 1, then this is an alternative to get your archive data into the cloud. And again, just to prove that we can move data about across on-prem and Azure. Just run that. And so now I'm going to do a copy from the on-prem table into table 2. And you see, performance-wise, it's very quick as well. So let's talk about trying to get Stretch enabled. So we're going to do what I said we had to do and configure the instance for Stretch. And I'm going to now show you the Stretch wizard. One thing I will tell you though is this machine was supposed to be release candidate 3. It's a release candidate 3 image on Azure, but it seems to be release candidate 0. So the Stretch wizard is not the one that you'll be seeing when you come to try this. So enable Stretch. So the validation is done on these tables. These are fine. I'm going to select T1 because that, if you remember, is the one that's actually on-prem. Now T2 is the one that's in the cloud. I've got to sign in to my Azure account. No spams, please. Hopefully I've done it correctly. And yeah, we'll take that subscription, and I'm going to choose North Europe. So if you've got an existing SQL Azure database server, we can specify those credentials. I don't, and this is the bit that's going to take quite long. So let's fill in these credentials. Admin account name, well obviously my name is Retracement on Twitter, so it's probably a good thing. Password, I'm not going to tell you my password. Next. And at this stage we actually provide our database master key. You can put anything you want in there as long as you remember what it is and remember to back these things up. I forgot that one is already. What a fool. Next. And then we let the wizard itself try and punch holes through the firewall for us. And then finish. So one thing I didn't really tell you about in either the slide or this wizard is that the release candidate 3 wizard, you'll actually see capability to specify predicates. So these are the things that will filter your rows that you actually want to trickle across into the cloud. So you see that on the select tables option. And if you don't select a predicate, then all your rows are going to trickle across through your entire table, trickle across into Azure, and your manager is probably not going to be very happy with you. So we'll do a finish. Now that's either going to fail or take quite a long time to do. So we're not going to wait for that. Maybe we'll pop back at the very end, assuming time's permitting, because I can see we've got 9 minutes to run at most. So some new functionality now we're going to talk about in SQL 2016. Read-only routing change is pretty cool. I personally don't think this is the final solution to me, because I think we need a bit more functionality here. But we had a problem in the previous version of SQL Server when we used read-only routing. The problem is if you had any read-only queries, they would be routed to the very first server in your read-only routing list. Now what this always resulted in was that this first server would become very hot, even though you may have had like 2 or 3 readable replicas sitting there doing nothing. So they've introduced this change in 2016 where you use these parentheses to create a load balanced set, and this will then round robin your read-only queries across these replicas and obviously offload things. Now why do I not really think this is the finished solution? Well, the reason being is, let's say for instance we lost server 2 and 3 in my read-only routing list here, and let's say we're not losing quorum in this case. Server 4 would still be the one that's used. In order to use 5 or 6 would have to lose all 3 of those servers. So what I really want Microsoft to introduce here is I want them to provide us an ability to actually implement logic. If I've only got 1 server left in my load balance set, please use my next read-only routing list or my next load balance set. So I personally think this is a great improvement, but I think there's a little bit more work to be done here. So some of these things have been talked about by Kevin Farley in the past summit 2015. If you can get his session and watch it, I would highly recommend it. He talks about something called direct seeding. So if you imagine that when we're creating our secondary replicas, we always had to back up our primary. So generally you do a full backup of your what would be the primary replica database, and then back up the log, and then apply those with no recovery to your secondary replicas. The problem there is obviously we're pushing our I/O to some location somewhere, and it could be your databases would be very big. So what they've introduced is the ability to seed directly over a replica backup stream directly to the mirror port, and this will mean we don't have to do these backups anymore in this manner. So this would be a very quick way to get your secondaries up and running. So I think that's pretty darn cool. Quite a big change really is domain independent availability groups. So we now have the ability to utilize Windows in a non-domain configuration, and this is really going to be the thing that kills database mirroring, or one of the things. We've got basic availability groups as well, which is going to be the second thing, which I'm not talking about. And yeah, so this is going to be quite an interesting thing, because if we can deploy availability groups across domain independent locations, so we could have two work groups, then that also provides some interesting scenarios for utilizing the cloud as well. We no longer need to do any funky stuff with the cloud in order to have availability groups spanning the cloud. And also talking about that, this is potentially a step further of making the cloud easier for our availability group solution, because generally I would argue at the moment the use of the cloud in our availability group solution is primarily for what I would maybe class as a highly available DR site. So what we have now is in 2016, and I don't believe this is going to be out until the first service pack, maybe beyond, but we're going to have distributed availability groups. So those of you out there who understand Oracle Data Guard, this is a similar kind of technology. We can now have availability groups that can be configured and then shipped to a secondary availability group over an asynchronous replication stream. So we will no longer have really difficult configurations into the cloud if you want to use this type of deployment. But as I say, I don't believe this is going to come with RTM. I believe this will be out in probably Service Pack 1. So that really wraps it up for me. Or let's just see though before, sorry about this Sharon, let's just see how my wizard got on though before we do wrap up. Great. So we can see now that Stretch did actually work, and I will very quickly show you, if we look on the SQL databases, I will show you that it's automatically created our SQL database, and it will have trickled all my data across into this database because I didn't set a predicate up. If you are trying this at home, be careful because I have found this particular thing to be quite costly for me personally. I'm sure you could provision a smaller sized database, SQL Azure database though. So thank you very much for listening. I'm open to any questions now, and I'm handing it back to Sharon. Thank you very much.
Thank you, Mark. There are just a couple of questions. If I plan to have an Azure VM as my secondary always-on availability group replica, does my primary on-premise SQL server need to have an internet connection?
Yes. This is one of the biggest problems really with availability groups. I mean, obviously you're going to need connectivity just on the basis that the changes to the primary have to be automatically either synchronously or asynchronously shipped across into the cloud. But we have the Azure Replica Wizard introduced in SQL Server 2016 to make that experience a little more simple. But the thing I don't really like is we need to have the networking side of things set up in Azure as well, which for me, and there's also some Active Directory considerations as well. So yes, you do need that connectivity, and it's not, it's not a very simple thing to do.
And CSV means a LUN from a SAN device, right? If so, if the SAN goes down, the CSV is also down, correct?
Yes, so all the CSV gives us, it's just a simple wrapper, a high availability wrapper around a LUN, and we have all the same considerations in terms of availability to that LUN. If your SAN, and let's remember that SANs are supposed to provide availability to our storage, if that LUN does go down, then yes, your CSV will be down.
Okay, that's it for the questions. Next slide, please. The next presentation, presentation number 23, is a new paradigm for performance tuning in SQL Server 2016. Next slide, please. Thank you, Mark, for your excellent presentation. And I really enjoyed seeing all those pictures of cats since I'm doing this moderating with a large Maine Coon cat sat on my other computer. Thank everybody for coming. Keep in touch. Follow us on Twitter at PAS24HOP and share your thoughts with the hashtag 24HOP. Thank you all. Have a pleasant day, pleasant evening. If it's gin time where you are, enjoy. It's breakfast where I am, so bye.
Bye. Thanks very much, Sharon.